Hello, everybody. We are going to get into your second worksheet of this particular unit. This is basically how to do mole-to-mole stoichiometry problems, okay? So, as always, what I like to do is I like to refer back to your molar map, right? So I'm going to draw you a little representative guide of your molar map. If you have you know what? Let me see if I can pull up the molar map on my computer, and then I can just show you on there. So give me a second. Okay, here is your molar map. Okay. If you guys watched my video on how to use your molar map, this is the video that I recorded for you guys, and I left some of the color-coded items there. Let me get rid of some of this stuff just so it doesn't confuse you, because we're obviously working with some different elements, but the concept is essentially the same. Okay, so let me get myself reset. While I'm doing this, please take out your molar map so you can walk through with me, okay? So we talked about how to write the mole ratio in your first worksheet. This worksheet is going to be all about using the mole ratio to convert from moles of one substance to moles of another substance, okay? So essentially what we're going to be doing is I am going to highlight what we're going to be focusing on for this, and we are going to be focusing on this section of the map right here. Okay, that's what worksheet 2 is all about. That is our focus. Okay, so our focus is we are going to be converting 1 mole of a substance and determining how much of the other substance in terms of mole that we create or that we produce. Okay, so hopefully that was helpful. All right, let's go back to what we were doing. We were looking at our second worksheet. So what I'm going to do, because I want you guys to be aware of how important that molar map is basically to your existence. In the top of this page, I am just going to, let me make sure I get the right pen and not a highlighter. That would be a great thing right there. So I'm going to get a pen. Up here in the corner, I am just going to make a little depiction of your molar map. Okay. So this is the part of the molar map that we are going to be working with. Okay. We are going from mole to mole. Please remember, right, we have that division in between on your molar map. And then we are going to use, and I'm going to abbreviate mole ratio with MR. Okay? So the first thing that I do for all of these problems, and I know you hate to hear me say this, is I'm going to build a roadmap. All right? So in problem 1, I already have a balanced equation, which is awesome. It looks like the conversion took away some of my arrows. Not a big deal. I'll put it right back in for you. Okay. So we have ammonium that combines with sulfuric acid and makes ammonium sulfate. The question is asking you, you have 3.5 moles of sulfuric acid. It wants to know how many moles of ammonium you need for the reaction to happen. Okay. So I know everybody hates word problems, so that's why I always write out a roadmap. So when I'm writing out my roadmap, I'm going to start with what I know. So in the problem, it tells me the number of moles of sulfuric acid, and I am trying to make my way to moles of ammonia. When doing this conversion, you know that you're going to use the mole ratio. So keep that in the back of your mind. All right, let's set up the problem. We're going to set these up just like the other conversions that we did at the end of the semester. Remember, we're only doing a 1-to-1 conversion. I broke down all of the conversions, training wheels, right? We're just going from mole to mole. So I'm going to start with what I know, which is 3.5 moles of sulfuric acid. As usual, we're going to take what we know and we're going to put it over 1. Then we need to figure out what conversion factor we are going to use. We are going to get that conversion factor from the mole ratio in the equation. Okay? So we are converting or trying to convert between sulfuric acid and ammonia. Okay? So those are the coefficients that I'm going to look at. So my coefficient for ammonia is going to be 2, and my coefficient for sulfuric acid is going to be 1. Right, remember, no coefficient is an implied 1. You definitely want to make sure that this equation is balanced, okay? And it is, all right? I think the other ones you're going to have to balance, and any one that you have to balance, you'll have a line before the element saying you need to figure out what the coefficient is. Okay, so now we know that we are going to use our mole ratio. We have moles of sulfuric acid in the numerator. That means I need moles of sulfuric acid in the denominator. The moles that I'm converting to are going to be moles of ammonia. That means that moles of ammonia are going to be on top. Now we need to take a look at the coefficients. I have a 1 in front of sulfuric acid. I have a 2 in front of ammonia. So that is going to be a 2-to-1 relationship. Okay? Now remember, guys, your units need to cancel to make sure that this all works out the way it's supposed to. Let me get rid of some of these arrows. So if you take a look at your units, moles of sulfuric acid cancels, moles of sulfuric acid cancels, and then all you need to do, and you can do this in your head, but you can take out your calculator too, that's why you have it. You're going to take 3.5, you're going to multiply by 2, and that's going to be your answer. So your final answer for conversion is that you are going to end up with 7 moles of what? Ammonia. And that is the answer to A. Okay, hopefully that was helpful. All right, so we are going to go through some of the other problems just so that we can try and figure out what's going on with the rest of these. I think you have 14 to do. Okay, so I will be doing a few of them, and then I'm going to let you do a few of them. So the ones that I'm going to do, I will definitely do number 2, because that one is already balanced. You don't have to worry about the balance, so that's what we're going to do, right? I have 2 oxygen, 1 oxygen is 3. Okay, so once again, I don't know what was going on with my formatting, but if you just put that arrow there, okay, then that's where the arrow is for the equation. Okay, so it says if 15 moles of water are produced, how many moles of nitrogen are produced? All right, so we are going to write out our map. What are we going? Where do we start with? Where are we going? In the problem, it gives us moles of water. Okay. And then it's asking us how many moles of nitrogen are produced. Okay, so once again, you're converting from moles to moles. Okay, remember on top, converting from moles to moles, you were going to use the molar ratio. So that's what I have depicted right there. So let's write it out. We are starting with 15 moles of water. So we have 15 moles of water. Remember, what you know, put it over 1. And now you need to figure out what conversion factor to use. Okay? We are starting with moles of water. We are trying to get to nitrogen. Moles of water in the numerator, moles of water in the denominator, and we are going to moles of nitrogen up top. Okay, so I'm hoping you guys are seeing how important your units are for these problems, because if you don't have your units right, you may not multiply or divide properly. Okay, so now we are going to get our mole ratio from our equation. So if you take a look, the coefficient for water is going to be 4, and then the coefficient for Nitrogen is going to be 2. So we are in a 2 to 4 relationship. Now all you're going to do is do the math. You know, your units cancel and you end up where you're supposed to be because the question is asking you for moles of nitrogen. It is 15, basically divided in half. So it is going to be, oh, let me get my pen situation correct. It is going to be 7.5, and the unit is going to be moles of nitrogen, and that is the answer for number 4. Okay. Let's do one other problem, and I'm hoping that by the end of that, you should be pretty, at least proficient at doing these problems. Okay. Let's deal with number 2. Okay, so for number 2, we have an added step. We actually have to balance the equation. So if we take a look, I have 2. Oh, wait, hold on. Let me fix my formatting problem and put in my arrow. I have 2 iron on one side. I have 1 iron on the other. That means I need a 2 here. I have 2 aluminum on the right side. I only have 1 on the left side. That means that I need a 2 here. And that is my balance. Okay, so now we can go about trying to solve the problem. So it tells us that we are starting with moles of iron metal. And we are trying to find out how many moles of iron 3 oxide, let me be clear, are going to be required for this reaction to happen. Remember, you were going to use the mole ratio to do your conversions. So now let's set it up. We have 5.6 moles of iron. Take what you know, put it over 1. And then you need to figure out what you're using for your conversion factor. Okay? So we know that we are comparing iron and iron 3 oxide. That means that I am comparing a coefficient of 2. Remember, with that implied coefficient of 1. So I have moles in the numerator of iron. I need moles of iron in the denominator. And I need to get to moles of iron 3 oxide. So now let's take a look at our coefficients to figure out what our mole ratio is. We are in a 1 to 2 relationship. You always want to check to make sure your units cancel. Moles of iron. We are where we need to be. It's asking you for moles of iron 3 oxide. Essentially, what you're going to do is you're going to take your calculator. You're going to take 5.6. You're going to divide it by 2. You're going to end up with 2.8. And the unit is moles of iron 3 oxide. And that is the answer for number 2. Okay. I guess we could keep moving along. Let's do number 3. I got to give myself some space, though, if that's the one that we were going to do. I guess I didn't really think about how many of these equations that I would do, but I will do as many as I can just to help you out. Okay, so the first thing is we need to balance. This equation is going to be interesting to balance, right? So here's the deal. Now, this is a trick that I talked to you about in first semester. You have a 3 here, and you have a 2 here. When you see 3's and 2's, put 3's and 2's. Okay? So first things first, let me correct my little formatting business going on here. 3's and 2's, I have a 2, I have a 3, and now let's see where we stand. Okay, so it looks like I now have 2 nitrogen and 2 nitrogen, and I have 6 hydrogen and 6 hydrogen. Okay, I'm balanced. I don't know why I thought that was going to be harder. All right, so now we got to solve the problem. So it tells you that you're starting with moles of hydrogen. and it wants to know how many moles of ammonia are produced. To make this conversion, we are going from moles to moles, so we're going to use the mole ratio, and then we are going to take a look at our equation and figure out what's going on. So we are starting with 12.4 moles of hydrogen, put it over 1, and then figure out what conversion factor we need to use. So the coefficients that we need to focus on, we are looking at a coefficient of 3 for the hydrogen, and we're looking at a coefficient of 2 for the ammonia. So moles of hydrogen are in the numerator. That means I need moles of hydrogen in the denominator, and I'm trying to make my way to moles of ammonia. Okay, so if I take a look at my coefficients, we are in a 2 to 3 relationship. So now what you're going to do, take out your trusty calculator. Hopefully it will not lead you astray. You're going to take 12.4, you're going to multiply by 2, and then you're going to divide by 3, and you will end up with an answer of 8.27 moles of ammonia. Make sure that your units cancel, and that's exactly what it is. And it is. The unit left is going to be your moles of ammonia. Okay, so that is the answer for number 3. Okay, let's jump around a bit. Let's go to number 6. So for number 6, first things first, let's deal with our missing arrow. So we have a single replacement reaction, right, where magnesium is swapping places with silver. Now we just need to figure out how to balance it. So let's do that. I have 2 nitrates. I have 1 nitrate. I need 2. Okay. And then now I have 2 silver, so I need 2 silver. And if I can add, that is our balance, I believe. We have 2 nitrates, 1 magnesium, 2 silver, 2 silver. All right, so let's set it up. We are trying to go in the problem. It is telling us that we have 7.25 moles of magnesium that are used in a reaction. It is asking you how many moles of silver are produced. As usual, we are going to use the mole ratio because we are converting from mole to mole. And then we are going to set it up. 7.25 moles magnesium. Put it over 1. Now, we have moles of magnesium in the numerator. That means I need moles of magnesium in the denominator, which means that my moles of silver are going to be on top. Now we need to take a look at our coefficients to figure out what our ratio is going to be. We have a coefficient of 2, and then we have a coefficient of 1. So our ratio is going to be 2 to 1. Okay, so take out your calculator. Take 7.25, multiply by 2, and that should give you the answer. So the final answer for this problem is 14.5, and it should be moles of silver. Make sure you check it. Moles of magnesium cancels, you're left with moles of silver. That's what it's asking you for. Okay, that is the correct answer. All right, hopefully you're starting to see the redundancy of these equations, okay? Let's pick one where you have to predict some products. So let's go with number 10. So for number 10, you need to predict what the products are going to be. So I'm going to put my little arrow here. And if you take a look, you guys should realize that this is a double replacement reaction. So the like charges are going to swap places. So in this case, it is going to be calcium. It is going to be silver because they are both positive. So now calcium is going to be chilling with nitrate. And then silver is going to be with chlorine. Okay? Check your charges. Please do not forget this. Check your charges to make sure your formula looks the way it's supposed to. Charge on calcium is +2, nitrate is -1. Silver, transition metal, remember it's an exception, it's always +1. Chlorine is a halogen, it is always -1. So if we were to write the correct formula, it would be Ca parentheses NO32, and then silver chloride is correct. Okay, please make sure that you always do that to make sure that your balance is going to be right. Because if your balance is thrown off, then that means that your calculations are going to be thrown off for your molar mass. I'm sorry, for your mole ratio. Woo! Okay, so here's what we need to do. We need to balance. So problem children, I have 2 nitrates and 1 nitrate, so I need 2. I have 1 silver and I have 2 silver there, so I need 2 here. And then I think I'm good. 1 calcium, 2 chlorine, 2 chlorine, and this equation is balanced. Okay, if it makes you feel better, please put in your coefficients that are really there that we don't write because it's 1. Okay. And if it makes you feel better, put a line underneath it just so you can keep things consistent. Now we can solve the problem. The problem is telling you that you start with moles of calcium nitrate, and it wants to know how many moles of calcium chloride are you going to use in this reaction. Just like all the other problems on this worksheet, you're going to use mole ratio. You're starting with 5 moles. Ooh, my pen is getting tired. You're starting with 5 moles of calcium nitrate. Remember, put it over 1. Now you have moles of calcium nitrate in the numerator. That means you need moles of calcium nitrate in the denominator. And you are going to moles of calcium chloride. Okay, so check your coefficients. You have a coefficient of 1. Oh, and a coefficient of 1. So this question is a lot simpler than it should be. Okay, so you have a 1-to-1 relationship. So guess what? Your moles are equal. So if you have 5 moles of calcium nitrate, you have 5 moles of calcium chloride. Okay? Make sure that your units cancel, and they do, and you're left with what you're supposed to be left with, and that is your answer. Okay? I am going to let you guys figure out the rest of them. They're pretty self-explanatory, pretty repetitive, but remember, we always start with each individual step. So the first worksheet was just how to figure out the mole ratio. The second worksheet is how do we use that mole ratio to figure out what's going on in our equations. Okay? So hopefully that was helpful.